Hi, so we're going to do some graphing of inequalities this time, and you should have done some plotting of line graphs before. We're going to look at some other simple types of line graphs before we get into the graphing inequalities bit though. And today you really do need to concentrate. You can't have this on in the background whilst you're playing Snake on your Nokia 3310 or whatever it is. You need to really be paying attention, okay? Right, first of all, so let's do some horizontal and vertical graphs. Just basically straight line graphs that are straight across or straight up and down. Before, we've always had them in the form of y equals mx plus c. So y equals something x plus or minus something. Okay, and that's, the gradient is m and the y-intercept is c. But this time we're going to have ones that look maybe more like this. So y equals 2. So there's no x in here now. So actually what we're saying is this is going to be any point where the y part of the coordinates are 2. So that could be x is 0 and y is 2. Or it could be that x is 1 and y is 2. In fact, it doesn't really matter what x is. It could be anything as long as the y part is 2. So we're going to plot all those points because, we want all the points where y equals 2. So that could be here, y equals 2. Or here. Or maybe here, or here, or here, or here. All of these points, y has the value of 2. And if you notice, it goes straight through. It's a straight line passing through the y-axis at 2. All right, so cuts through the y-axis at 2. So there's a bit of a sort of clue to that. That is y equals 2. There's no constraint on the x values because it goes infinitely off to the left and infinitely far off to the right. But the thing they have in common is that all the points have y equals 2. Similarly, if we had y equals negative 4, that's going to be all the points where y equals minus 4. So, for example, 0, minus 4. Just as long as that second part is minus 4. So there's 1 point, another point, another point. You get the idea. Okay, so if we've got a graph of y equals something, it's a horizontal line. All these ones where y equals something is going to be a horizontal line. All right, through that axis at that number. So y equals minus 4, put it through there. So for example, y equals negative 2, find negative 2 on the y-axis and put a line straight through it like that. It's annoying, the graph keeps disappearing, isn't it? Then x equals 4. So similarly, this is going to be all the points where x equals 4. So it could be 4, 0. It could be 4, 1. In fact, it could be 4, anything. Right? As long as the first number is 4 for our coordinate. So, for example, here's a point where x is 4. X is 4 here, and here, and here, and here, and here, and so on. Okay, all of these points, x equals 4. So that's a straight line vertically. And in fact, that's going to be right. Anything where the graph is x equals something, you're going to get a vertical line through the x-axis at the point of 4, like that. So x equals negative 3. Where's negative 3 on the x-axis? There's the x-axis, there's negative 3. It's going to be a vertical line going through there because we want all the points where x equals negative 3. So the one I did, and this one, 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 and this one. Okay? That is x equals negative 3. Right. So again, x equals 2. If you've got one of these graphs where it's either y equals or x equals, on that axis, in this case the x-axis, so the one going across, put a point at the number it says, at 2, and then put a line going straight through it, perpendicular to the axis, yeah, at a right angle to it. And that is x equals 2, which for some reason has gone over there. Maybe I should label it myself. X equals 2. Okay? And we could turn this into a pair of glasses. Great. Okay, moving on. So what about, there's one other type as well which you're going to chuck in here, which aren't horizontal or vertical. These ones are the ones that are diagonal. And so, for example, y equals x. Now that simply means whatever the point is, the y value equals the x value, so 0, 0. Or if x is 1, y will be 1. On Earth, y will be 1. And then 2, 2, and 3, 3. And so you get the idea, okay? So you end up with this, particularly if it's a kind of symmetrical graph with the same scale on the axes, you just get a diagonal line going through there. That is y equals x. So that's one to remember. The horizontal graphs, the vertical graphs, y equals x, but also y equals negative x comes up quite a bit as well. Now this simply means that whatever x is, y is the opposite. Or rather, let's do it the other way around. So if x is 1, y will be minus 1. So 1 across, 1 down. If x is 2, y will be minus 2. So 2 minus 2. And, conversely, if x is minus 1, y will be positive 1. So it's the same numbers, just the other way around, right? Okay, so you end up with this diagonal line going that way. It's the sort of, the other graph just rotated through 90 degrees. Okay, so y equals x, diagonally straight up. Y equals negative x, diagonally, but going downwards with that negative gradient that it's got. So horizontal graphs look like this. Y equals something. So for example, y equals minus 2. And vertical graphs look like this. X equals something. So x equals 3. Just whatever axis it goes through, at whatever point, you can write that down as your graph. You'll get the idea, okay? Because what I want you to do now is there's 6 graphs here. A, B, C, D, E, F. Oh, why have I not got a pause button on there? That's really annoying. I'm going to write pause. That's a bit unlike me. I usually have my pause button sorted out fine. Right, I want you to pause the video, write down what the equations are. Don't just do them in your head. I want you to actually write them down, please. Okay, unpause when you're done. Right, we have unpaused. So A, it's a vertical graph, and it goes through the x-axis at 2. So that needs to be x equals 2. Right, B is that one that's diagonally up. If you're not sure, look at points. I've got a point 1, 1, 2, 2, 3, 3, 4, 4. All the y values are the same as the x values. So y equals x. Now, if you put x equals y, actually that's technically correct as well. Just by convention, if we've got y and x in the graph, we'd usually put the y first. But you could have x equals y. Same thing. C. This one is a horizontal graph, and it's going through the y-axis, so it goes through the y-axis at the point where y equals 2. D. D is down here. That goes through the y-axis as well, so it's y equals. And it goes through at negative 3. E. I've got a diagonal graph going down, and it's, if you're not sure, just pick a point. So y, x, what's this coordinate? This is 1 minus 1. This coordinate is 2 minus 2. So basically, y equals the negative of x. Now, we wouldn't generally write this as minus y equals x. I mean, it's technically not wrong, I suppose, but we wouldn't usually write that. So y equals negative x. F, vertical graph. It goes through the x-axis at the point when x equals negative 4. Okay, off to Dr. Frost with you. There's just a few questions to do in there. I can't remember how many there are, but there's just a few in there. Identify the graphs and write them in. Do all of them, please. Make sure you get them right. You can always redo them. And then come back and see the rest of the video. So pause it for now, go do Dr. Frost, and then come back. So now we're going to look at actually graphing these inequalities, showing the range of answers for these. Because remember, inequalities represent a range of answers, not just a single solution. So now we can actually kind of represent this on a graph. And it's to start off with, at least, it's pretty straightforward. So we can show the range of answers as a region on the graph. So that's an area. So I might decide that, that's the area, and I shade it in to show the area where all the solutions to the inequality are. But well, it's a bit more specific than that. So shade the region representing x equals greater or equal to 2. Greater than or equal to 2. Okay, now we could do this on a number line. You'd know you put your filled in circle above 2 and the arrow going to the right. But on a graph, we're a little bit more two-dimensional than that. So the first thing to do is actually draw the graph. Imagine that we're going to draw the graph of not just x is greater than or equal to 2, but just x equals 2 itself. Just find that graph. So we want the x-axis at the point 2 and put that vertical graph going through, which is why we started with that. So that is x equals 2. And then decide which side of the graph you're going to shade. Now I want all the points where x is bigger than or equal to 2. Now if you're not sure, just pick a point, and see if that satisfies it. So if I pick this point here, that point is 4, 1. Is x bigger than or equal to 2? Yes, it is. So you shade that side of the graph. Okay, so if you're not sure which side to shade, just pick a point and see if it satisfies the inequality. If I picked a point over here, this point is -3, 1. Well, x is not bigger than 2. So it's not going to shade that side. So pretend that it's just, in this case, x equals the 2. Don't worry about the inequality, just equals. Draw that line and then shade it in. Notice I've used a solid line here. Probably didn't think about that because, it's always a solid line, isn't it? Isn't it? Well, I don't know. Let's have a look. What about if I wanted to do just x is greater than 2? Well, same thing. We're going to do, just pretend for the minute that it's actually x equals 2, just like we did before. Where's x equals 2? Well, that would be here. And so draw a line. But this time, so that's x equals 2. It's dotted. Now it's dotted because it's just greater than. There's no equals on there. Now if it's dotted, it's a bit like the open circle when we do it on a number line. You put a dotted line there. And because it's greater than 2, I'm shading that side. Again, if you're not sure, just pick a point. Write down what the coordinates are. Is x bigger than 2? Yes, it is. Shade that side. So here's the important thing. If it's less than or greater than, use a dotted line. If it's less than or equal to or greater than or equal to, use a solid line. So that's the difference. Again, just like the open circle or the closed circles, you use a dotted or a solid line. Right, onwards. Let's do some more. So y is less than or equal to -1. Again, instead of doing the inequality initially, not 2, it's -1. Initially, just do the graph of y equals -1. So the y-axis at -1, and remember, put a line straight through it. Now it's a dotted line because it's less than or greater than. Just use a dotted line, and then decide which side you're going to shade. So pick a side, pick a point, write down the coordinate of it. So that's -4 across and -3 down. -3 is less than -1, so it must be under there. I need to shade. Shade under the line. All right. So draw it as a straight line. Decide which side to shade. Shade it in. Just be careful if it's a dotted or a solid line. What about y is less than or equal to x? I'm just going to move the cat out of the way. Come on, cat. I know, cat. I know. Just go stand over there. Right. Y is less than or equal to x. So, first of all, don't worry about the inequality. Just graph y equals x. There it is. It's that diagonal line, isn't it? Notice it's not going corner to corner because it has to be y equals x. So, that point there is 8, 8. If I put it up here, that would be at the point 8, 9. So, it's just because the graph isn't quite symmetrical. Anyway, that is y equals x. And then I need to shade the bit where y is less than or equal to x. Again, pick a point. Write down that point. So, -2, 3. Is y less than or equal to x here? Well, no, y is bigger than x. 3 is bigger than minus 2, so that's not that side. I need to shade under the line. Just like that. Alrighty. Then, you happy with that? Yeah? And it's a solid line because it's less than or equal to, so it needs to be solid. Right, 4 for you to do. What I want to do is have a look at these and write down what inequality they represent. Look at where the line is. And then look at which side is shaded, so is it greater than or less than that point, and also decide what sign you've got to use, is it solid or dotted. Pause, unpause when you're done. Very important that you write these down, possibly even write examples so you've got something to look at in the future. Right, I've unpaused. Well, firstly, this line here it's going through the x-axis at the point where x equals -3. So I'm going to have x, I'm going to have -3. I've just got to decide on the sign. Now it's that side of the line that's shaded, which is the numbers bigger than -3, and it's dotted, so I don't need the equals to. So x is greater than -3. Right, this line here, if you didn't get that right or you're confused, maybe pause now, do the next 3, and then unpause. Cool, so this one is going through the y-axis at the point where y equals 1. So we're going to have y, we're going to have 1. Now it's shaded under that line, which covers all the points less than 1. And it's solid, so actually it's y equals less than or equal to 1. Right, this line here that's that good old y equals x. All the points y and x are the same, so it's going to be y and x. It's which side have we shaded? We've shaded that side, so let's pick a point and just write down what the coordinate is. That's -2 and 3. Well, 3 is bigger than -2, so y is bigger than x because the y bit is bigger than the x bit. It's a dotted line, so that's it. I don't need the equals, it's just y is bigger than x. All the points in that shaded bit have the value of y being bigger than x. This line here goes through the y-axis at the point where y equals 3. And it's shaded on top of the line. So we've got y and we've got 3. It's shaded above it, and that's all the bits where y is bigger than 3. And it's a solid line, so I need the equals. Y is greater than or equal to 3. Easy peasy, right? What about if we've got a two-sided inequality though? So it's bounded by two different numbers. Very similar thing. Now the thing is, you've got to particularly read this part of the inequality correctly. The other side's easy. That's, x is less than 3. But this side, think what it means. Look at which side the x is on. We're going to kind of flip it round, okay? To be x is bigger than or equal to -2. That's what that says, read in the right direction. You could read it as -2 is less than or equal to x. But that's not very helpful. So x is bigger than or equal to -2. And draw that line in. There it is. It goes through the x-axis at the point where x is -2. And then this side of the inequality is pretty easy. It's written for you. X is less than 3. So we'll put a line through where x is 3. So x equals 3. Oh, why did I do that? Should be an equals up there. Then you've got to decide which bit to shade. Well, x is bigger than or equal to -2. Again, if you're not sure, draw a point. But all of the points that side of that line are bigger than -2. But x is also less than 3. So there's x is 3, which means it's got to be less than that one. Basically, we want the bit that's bounded by these two lines, the bit in between the two lines. Again, if you're not sure, pick a point, look at the values. Oh, we've got a whole cat-dog situation going on. Cat, why don't you just get back on the table? Okay, this one. You might want to pause this and think for yourself what it is. I'm just going to keep going. Again, let's just write this left-hand part sort of the correct way round. So it's y and 2. Look, y is bigger than 2. So we can put that line in at y equals 2. It's dotted because it's just y is greater than. There's no equals there. And then the other side of the inequality, y is less than 5. So we find 5 on the y-axis, put a line through it. And this time it's also dotted because y is just less than 5. There's no equals. And then think about where you're going to shade. X is bigger than 2. Well, if I'm bigger than 2, it's got to be above that line. Again, draw a point if you're not sure. But also, y is less than 5. Well, there's y equals 5. Anything less than that is under that. So it's in between those two lines that I want to shade. Moving on. Try these then. So work out what the two lines are. Make sure you've got the right sign. And then write it. I want it written as a single inequality. So you might have, I don't know, minus 2 is less than or equal to y, which is less than or equal to 4. What I want something like that written as a single inequality. I'd write it as two parts to start with, and then as a single one afterwards. So pause and unpause when you've had a really good go at those. Okay, now if you're finding this tricky, then don't be surprised. It is hard the first time you see it, particularly you haven't got these on paper. You can't sketch all over it because it's on screen. It does make things harder. But let's just see what we can do. Firstly, let's write down what these lines are. That goes through the x-axis. X equals minus 1. And this one goes through the x-axis at x equals 4. So x equals 4. Those are my two lines. X and minus 1. Well, it's all the stuff to the right of that line, which are all the numbers where x is bigger than minus 1, but it's dotted, so I don't need the equals. And this one, it's actually all the stuff to the left of that line, so x is less than 4, but it's a solid line, so x equals less than or equal to 4. So if I'm going to bound that by an inequality, use those two signs that I just found, just make sure that they are correct way round. They're always pointing to the left. X is greater than minus 1, but less than or equal to 4. Let's use another colour. Keep these separate. Okay, these go through the y-axis, don't they, each of them, which means they're both y equals graphs. Y equals, in this case, y equals 3. No, not 3. That's 2, isn't it? Y equals 2, and y equals negative 1. Then we've got, we're doing everything under that graph. So y and 2, it's everything where y is less than 2. It's dotted, so there's no equals sign. And the lower one, it's everything above that, so that's everything bigger than minus 1. So y equals, y is greater than minus 1. And then put that in a single inequality using those signs you found. Just you need to kind of flip this the other way so it reads the other way round. Y is greater than minus 1, but less than 2. With no equal signs because they're both dotted. Over here, right, this one goes through the x-axis at the point where x equals 0. And this one goes through the x-axis when x equals 5. And they're both solid. Now we're to the right of this one. So x is greater than or equal to 0 because it's a solid line. And this one is x equals, it's left of that, which is all the numbers less than 5. So x is less than or equal to 5 because, again, it's solid. If you wrote that as a single inequality, it would look like this. X is greater than or equal to 0, but less than or equal to 5. And last one, let's go for some cool magenta on this one. Okay, goes through the y-axis at the point where y equals minus 1. And this one goes through the y-axis at the point where y equals negative 4. Now it's everything under that line, but over that line. So hopefully your two inequalities would be y equals greater than -4. Come on, come on, cat, up here. Otherwise, we're gonna have a dog-cat fight, aren't we? You absolute nana. Right. Sorry, got distracted by the cat. Y is less than -1, but it's less than or equals to -1 because it's a solid line, and as a single inequality. Be aware of which way round you're putting that, because negative numbers are smaller. You know, -4 is smaller than -1, so it's that way round. There you go. Okay, if you're not sure about that, definitely just rewind, rewatch stuff, listen to me talk again. So shade the region, this time bounded by two separate inequalities. X equals greater than 3, y equals less than or equal to 4. So we're starting to do stuff a little bit differently now. Firstly, again, just work with the straight lines. You know, pretend it's x equals 3. X-axis is there at 3. It's a vertical line going straight through, and it's dotted because it's greater than. So x equals 3. And this one, y equals less than or equal to 4. Well, just do y equals 4 for now. There's the y-axis, there's 4. Put a line straight through it. It's solid because it's equals, so that y equals 4. And then decide which bit we're going to shade. Less obvious this time, but just look at your inequalities. X is greater than 3. So there was my x line, the x is 3. I want the stuff bigger than 3, so that's to the right of that line. Again, pick a point if you're not sure and just see if the x value is bigger than 3. But then I also want x is less than or equal to 4. So less than 4, that's the y equals 4. We want the stuff less than that. That's the stuff under that line. So you shade the region which satisfies both of those things. So it has to be under that horizontal line, but to the right of this one. That means we are shading in here, or more accurately, that. In an exam, usually most people don't sort of shade the whole thing. They put some cross hatchings in to show the region, right? Okay, try another one. X is less than -1. So let's just do the graph of x equals -1 first of all. There's the x-axis. There's -1. Vertical line straight through there, and it's dotted because it's only less than, it's not equal to. So x equals -1. And the graph of y is less than or equal to x. So again, just do y equals x for now. And remember, that's that diagonal graph, isn't it, that goes up all the way to the points where 8, 8, or -8, 8, 0, 0, and so on. So that's y equals x. And then decide which side of each line you're going to shade. X is less than -1. Well, there's my x graph. Anything less than that -1 will be to the left of that graph. Y is less than x. Again, now if you're not sure, pick a point. One side of that line. That is 3, 1. Is y less than x? 3, 1. Yes, 1 is less than 3. The y part is less than the x part. So we are under that line. Okay, so we need the bit that's both under this line, but to the left of that x line. Well, the bit that satisfies both of those is this area here. I'm going to shade now. Can't shade up here because that would be above the diagonal line. And I certainly can't shade any of the others because it would be to the right of the x one. So look at each individual one. I like putting little arrows on just to remind me of each bit, and then decide which section satisfies both inequalities. Again, 4 questions for you to do. Write down the separate inequalities, and you can decide using the shaded bit whether it's less than or greater than. Okay? Pause. Unpause when done. If you're not sure, go back and listen to those 2 things again. And then unpause when you're done. Okay, unpaused. Right, this graph coming through here, it's through the y-axis, where y equals 2. And this dotted one is coming through the x-axis when x equals -2. Right, so y and 2. It's everything under that graph. So it's everything where y is less than 2, but it's a solid line. So it's y equals less than or equal to 2. The x and the -2, well, it's everything again to the left of that line, where everything is less than -2, but there's dotted, so there's no equals sign, right? So there's my two things. X is less than -2, and y is less than or equal to 2. I've had enough of magenta. Right, again, these two lines here, x equals, that's not x equals, is it? It goes through the y-axis. So y equals 2, and x equals 2. Okay, goes through the x-axis at 2. What are my two inequalities then? X and 2. Well, it's everything is to the left of that line. So x is less than 2, but it's equals as well because it's a solid line. And y and 2, well, it's everything above that. So actually it's everything greater than 2 because it's above that y line. It's not equals though because it's a dotted line. So x is less than or equal to 2 and y equals greater than 2. These two lines, that one is y equals x, and this one is through the x-axis at the point where x is 1. So it's x equals 1. Okay, it's to the right of the x equals 1, so it's greater than 1. But it's also equals 2 because it's a solid line. And the y equals x, well, it's underneath that. Pick a point. That's 4, 2. Well, the y part is less than the x part, so y is less than x, and it's a solid line, so put equals 2 as well. Over here, what have we got? We've got two lines. This one is y equals -x. I knew I'd chuck it in at some point. Y equals -x, it's because it's going down. Then we've got this horizontal line here. It goes through the y-axis at 1, so y equals 1. So my two inequalities are, it's above the y line. So y is greater than 1, but it's not equals 2 because it's dotted. And y and minus x, well, it's to the left of that. Again, pick a point, anything to the left of that line. Okay, so pick a point. Now this is where it gets a little bit complicated. Okay, so we're going to pick a point, and I'm going to write down the coordinates. So that's 1 across, -3 down. And at that point, you might be going, well, y is less than the x1, so that's fine. But actually, remember, we're talking about y and -x, so you've kind of got to rewrite that coordinate as the y part is -3, and the x part, but we want -x, which means I've got to do -1. So is -3 bigger than -1? Tricky one, this one, isn't it? Is -3 bigger than -1? No, it's less than. So my sign is going to be less than, but it's less than or equals 2 because it was a solid line. When you're working with something like y equals -x, it's tricky. Find the point, but then, do the negative. You might, to be honest, you might have just looked at it and gone, well, it's under that line, so it's going to be less than. You can do it that way as well. Okay, last couple of things then. So we've got here an exam question. I'm just going to make things easier because this is the first time we've seen these. I'm just going to rewrite one of the equations in the form of y equals something, or y is less than something, okay? Draw the three lines on, try and shade the region. Just have a little go at this and see where you think it's going to go. Unpause when you're done. Okay, we might have got a bit confused here, but we'll just try and write down the things. Well, first of all, we're going to do x equals 2. So let's draw the line of x equals 2. That's here. And we'll do the line of where y equals x. That's the diagonal one. So y equals x. And the line of y is less than 6 minus x. Well, pick a couple of points. When x is 0, y will be 6. When y is 0, well, x must be, in that case, 6 as well to make 0, right? It's a diagonal line going through there. That might have been a bit tricky. Then look at your inequalities. X is bigger than 2. So on this line, we need to be to the right of that line. Wherever on that line, to the right of it somewhere. Y is greater than X. So we're going to be above this line. So anywhere above that one. And then y is less than or equal to 6 minus x. So on this line here, which is y equals 6 minus x, we want the bits under that line. So it's got to be under this line, but over this line, and to the right of this one. What you're really after, the area that satisfies all of those things, is in here. That is the region you're after, just in there. Okay? Can get tricky when you get these ones. Try another one. You can always pause, or if you get really stuck, just listen to my explanation. But I would like you to have a go. Okay, I've unpaused. Let's draw the 3 graphs first of all. So y equals 1 is there. Y equals 3 is there. And then y equals x we're going to do as well. Oh, sorry, I missed one, didn't I? Yeah, sorry, I was a bit confused then. X equals 0. Sorry, that's x equals 0. And then the y equals x is the diagonal. So let's find the bit where y is greater than 1 on that first one. So it's got to be above that line. But y equals less than 3, or less than equal to 3. So under that line, right? So it's somewhere in this corridor between those two lines. It's greater than 0 for the x. So it's got to be to the right of there. So again, we're in this kind of corridor here. But y is bigger than x, so it's got to be above that diagonal line. So in this corridor, but to the right of this line, this vertical line, and above there, you are after this area just in here. Yeah. So this is sort of where we go with this with GCSE questions. I think this is the last one. So we've got a region bounded by x. We've got y is greater than that. You know what you've got to do. Okay, so pause the video and pause when you're done. So a couple of things. Firstly, let's bound this area by x. So we've got 2 lines where x is -2 and x is 1. Let's put 2 vertical lines through there. 1, oh, that should be solid. I've made a mistake. So I'm going to change that. This one should be dotted where x equals -2, but this one should be solid. It's going to be a really badly drawn line because I can't draw straight lines on here. Oh, that's really bad. Okay, that should be solid through there. Sorry, apologies. So we've done both of those. That's x equals 1. Then we want y equals -2. So there's y equals -2. And this one, y is less than x plus 1. So it's like y equals x, but 1 higher. We shift it 1 up, so it will go through this point and then go diagonally up. So y equals x plus 1. Now, it's in between my 2 x lines. So it's to the right of that line, but to the left of that vertical line. So it's in this vertical corridor in the middle here. X is bigger than, y is bigger than -2, so it's above that line. So in that corridor, but above that line. And then y is less than x plus 1. So there's my y equals x plus 1. I want the bit under there. So it's under that line, but over this one. And in between these, it is this little funny shaped region in here, bounded by these edges. Yep, in there. And on a paper, you draw that much nicer than I have. Okay? Right, well done. It's a tricky topic when you first meet that, but I hope the basics of it are simple enough, just lots of practice in the future. Okay? Right, well done. And I'll see you next time. Bye-bye.